Dear students, today we can discuss about the Newton's laws of motion second part. It includes the string force and its connected systems. In the coming video, we can discuss about the spring force and frictions. Here, the motion of a block on a horizontal smooth surface. We can just discuss the three different situations. The first one, on a smooth surface, a block M is there and a pushing force F is acting on it horizontally. If you just consider the vertical forces, the weight is balanced with its reaction. So the movement is towards horizontal. We can easily say F is equal to M into A. So A equal to F by M. But the second case is very important, and here the pulling force is acting at an angle theta with respect to horizontal. How we can manage it? Keep in mind the very important point. We must convert that inclined force into horizontal and vertical directions. That means here that force F is splits into two components, F sin theta along vertical and F cos theta along horizontal. So in addition to the reaction, F sin theta is acting vertically. So here the balancing conditions are that R plus F sin theta is equal to mg. Therefore, R equal to mg minus F sin theta. Surely we can say the reaction is less than the weight. So we can certainly say there is no motion along vertical. Then we can easily say for its horizontal motion, the responsible one is F cos theta, that is equal to M into A. So you get the acceleration. The third case here, that pushing force is acting at an angle theta with respect to the horizontal. Here also, you need to split that pushing force F into two components. So if you just write the equation of motion along vertical direction, here we can say R is balanced with mg plus F sin theta. The motion responsible one is F cos theta. So we can write the acceleration as F cos theta by M. So these are the fundamental concepts we need to go with the higher order problems. See, the motion of bodies in contact. While discussing every problems, you should clearly sense what are the free body diagrams we are drawing, how we can write the equations of motion. So that is very important. So here, the two bodies A and B, M1 and M2, a horizontal force F is given. We need to find what is the contact force between them. See, look at the first mass M1. The horizontal force F is acting, but the contact force in between them, that is acting towards M1, that is labeled here. And just think about the free body diagram of B. So there is only the contact force F is acting towards it. So at first we need to find what is the total acceleration. So that is nothing but equal to the total force division by the total mass. Then you just go through the free body diagram of mass M1. So there the net force capital F, the applied one, minus the small f, the contact force, is equal to M1 into A. So we can find that contact force F. We can sense a simple shortcut there. Here, the applied force is acting on M1. Then you can just sense the other mass. That is nothing but M2 by the total mass into total force. So that is a shortcut. If here is another mass is there, then you have to add the 2. So you just find the mass in which the force is acting, then you can just take the other mass, the division by the total mass into the total force. So look at the question here. The 3 Newton force is acting on 2 kilogram. We need to find the contact force. So the other mass, what is that? 1 by the total mass. 1 plus 2 into the total force. You get the answer. But situation is different with another question. A good concept. Find the contact force between 3 kilogram and 2 kilogram block as shown in figure. Look at the figure carefully. Here the F1 force is acting 100 Newton. But here also another force 25 Newton is acting. We need to find the contact force capital N. So how we can write the equations? So at first we can just find what is the net force act on it. It is nothing but 100 minus 25, that is 75 Newton. So we can find what is the net acceleration. So F net by total mass. Then you just go through the free body diagram of 2 kilogram. So the contact force is acting. The 25 Newton force is acting. The weight reaction. Okay, fine. So we get the value as N minus 25, that is equal to the net force acting on it. That is nothing but 2 into the acceleration. We know the acceleration there, so you get the answer. Then how we can manage the 3 body system? Simply, we can go with one situation. See here. Already we said with one shortcut. Suppose we need to find what is F2. So you just find the mass in which the force is acting. Here M1. But here we need to find what is F2 at first. So you just think about the other mass. So it is M3. So F2 can be easily written as M3 by the total mass into total force. So how we can find F1? Simply we can just write the other mass. But here 2 masses are there. So you just add them. M2 plus M3 by the total mass into the total force. But we can prove by using the free body diagrams. So look at the mass M1. So here the contact force F1 is acting towards it and the capital F is acting. But for M2, horizontally you know that the contact force F1 is acting from it to contact force F2. But for M3 there is only one contact force M2. So you just add the 3, you get the value acceleration. And also you can put there and you get the answer. See another very good question. Find the contact force between the blocks and acceleration. You can work it so easily. So here it is given with the 3 masses 2, 5 and 3. The one is suffered with the force 50 Newton and 3 kilogram is suffered with the 30 Newton. As we done in the previous questions, at first we have to find what is the net force. 50 minus 30 equal to 20. So we find the acceleration as 2. Here we use the total mass as 2 plus 5 plus 3. Then you just look the free body diagram of the C mass, the 3 kilogram. The contact force N1 is acting. The force F2 is equal to 30 Newton is acting. So you can just write the relation as here the F50 is greater. So N1 should be greater. So N1 minus F2, that should be equal to 3 into its acceleration as 2. You get the answer. Similarly for 5 kilogram. So you can draw the free body diagram. So towards that N2, towards this one as N1, but it moves in the right hand side with a acceleration A. So you can just write the equation as n2 minus n1 equal to 5 into A. So you get the answer. So the situation becomes so easily. See, we can move to the another set of concepts, the connected systems. But at first we know the string. The three masses are connected between a string. Here the pulley system, the masses are connected with a string. Look the points carefully. The string is assumed to be inextensible. That is the very important point. Unless it is stated. So we can take the assumption as always inextensible. And that's the reason why the magnitude of accelerations of any number of masses connected through the string is always the same. So the acceleration of M1, M2, M3 are same. Next point, the string is assumed to be massless unless stated. That is the reason why the tension is uniform everywhere. So that is a very important one. Next point, if a string has a mass, the tension at different points will be different, being maximum at the end through which the force is applied, and minimum at the other end connected to the body. So look the figure. It got the maximum value here, minimum. And keep in mind, in order to produce a tension in a string, two equal and opposite stretching forces must be applied. We can move with some problematic situations regarding strings. The first one is a very good concept. When a string is fixed horizontally by clamping its free ends and loaded at the middle for equilibrium of point. So suppose this is the point P and is under equilibrium because of the mass, the weight W. So keep in mind the tension T can be split into two components, and this component become T cos theta and this component become T sin theta. And similarly this T can be split into two, this component become T cos theta and this component become T sin theta. And they will cancel. So we can say 2 cos theta equal to W, the weight. So when that tension become maximum, we can say the cos theta should got the minimum value. That will happen when? So we get the value T is equal to W by 2. A simple question are waiting. Good concept with the string. A mass of 10 kg is suspended by a rope of length 2.8 meter from a ceiling. A force of 98 Newton is applied at the midpoint of the rope as shown in the figure. The angle with which the rope makes with the vertical in equilibrium is. Look the steps we are following. The tension makes an angle theta with respect to the vertical here. So actually that string is like this one. Because of the horizontal force, it makes the angle. The tension can be split into two components. The two T cos theta vertical, T sin theta horizontal. At equilibrium, the T sin theta is balanced with 98 and T cos theta by 10 into 9.8. So you just divide it, you get the value theta is equal to 45. An examination question. So you get something about that string force. Then we can move to the next concept. Suppose there is a two-body string system. It is so simple. We can move as what we take in two bodies in contact. So there also the force is not acceleration is nothing but The total force division by total mass. Good. But what is the tension? You just look the mass where that force is acting. Then you find the concept. What is the next mass? Here M2. So M2 by the total mass into total force. You can go with the relevant steps also. Intuitive free body diagrams are drawing. We can write the simple relations and you can solve it too like that. And similarly for the three body system, what is the concept? So here the F is acting, you can easily find T2. Reason the other masses are what? M1 plus M2 by the total mass into F. Then what about T1? The force is acting here. So the other mass is what? M1 by M1 plus M2 plus M3 into F. Good. So here another examination question. It is waiting. The three masses are there as 1 kilogram, 8 kilogram and 27. We are giving a 36 Newton force. We have to find what is the T2. So simply the other masses M1 plus M2 by the total mass into total force, you get the answer. So that is a two body and three body system. So we can just move with another concept with a connected system. So read the question carefully. A 5 kilogram block has a rope of mass 2 kilogram. So keep in mind here the rope got mass of 2 kilogram attached to in its underside, and a 3 kilogram block is suspended from the other end of the rope. The whole system is accelerated upward with 2 meter per second square by an external force F0. Then what is F0? What is the force on rope? Then what is the tension at the midpoint of the rope? So we can just consider the two as a single system. So here the rope also got mass. So the total mass become 10 kilogram. So the weight 10 into G is acting vertically downward. That applied force F0. But the purpose is they must give an acceleration of 2. So you can just write the free body diagram equation as F0 minus 10 into G 100 is equal to S M into A. You get the answer. The second question is so simple. What is the force on rope? The mass of rope is 2 kilogram. The system must move with an acceleration of 2. So simple. M into A. And next question is, what is the tension at the midpoint of the rope? Midpoint of the rope. So that 2 kilogram is divided into 1. So with respect to that midpoint, what is the mass acting downward? The string contribution 1 kilogram. Here already 3. So 3 plus 1, 4. So that is acting vertically downward. So the tension in the upward direction. So T minus 4 into G equal to that. So you get the answer as 48 Newton. So we can just wait with another question. Find out the contact force between 2 kilogram and 4 kilogram block. An inclined plane concept. A good concept. See the question. We have to find what is the contact force between 2 kilogram and 4 kilogram in an inclined plane. It's a very good concept, but we know that 2 and 4 kilogram combined together, they is under motion with an acceleration of G sin 37. So on an inclined plane, acceleration of the block is independent of mass. So both the blocks will move with the same acceleration. Hence the contact force becomes 0. But look at the next question. Good concept. Find out the contact force between 2 and 3 placed on an inclined plane, but they are suffered with a force of 20 Newton in the upward direction. So you can just use the free body diagram. So here 2 plus 3, the 5 kilogram is there. So m1 plus m2 into a. So we can find what is the acceleration acting on it. So that is equal to 20 minus this component of the weight, that is equal to 5g sine 37. So we can written as 5a is equal to 20, the upward direction force, minus the force along the inclined plane, that is 2 plus 3 into sine 37. So we get the answer minus 2. Why minus 2? It is down the inclined plane. But we needed to find what is the contact force between them. So if you just look the 3 kilogram mass, its weight component is acting in this way, 3g sine 37. But the reaction given by the 2, that is acting in this way. But it is suffered with a 2 meter per second square acceleration. So simply you can written as 3g sine 37 minus n1 is equal to 3 into 2. You get the answer. Then now we can move to the pulley system. At first, when two masses m1 and m2 are connected with the tension T, so we can move with a simple concept. At the end, we can give a shortcut to solve such problems. So we can just go with the free body diagram of each masses. At first one for m1 mass, the weight m1 here in the upward direction tension. Suppose m2 is greater, so T is greater. So we can written as T minus m1g is equal to m1 into a. And similarly for the m2 mass, so it is coming vertically downward. So m2g is greater compared to T and can be written as. On solving, we get the answer as A. But you can think so with a short answer, how we can find the acceleration for the problem. So here the weight acting as m2g and here the weight acting as m1g. So you just subtract m2g minus m1g by total mass. So that is the acceleration for the system. If you specially consider all the systems like this, then you can easily find it. And here also, look here the weight acting is m1g and here there is no force. So m1g by total mass into g. So that is acceleration, simple. See, another concept is there. What is the reaction on the pulley? So in the first case, again, look here. So the two tensions are acting downward and hence the reaction on the pulley on that string is 2T. It is a very important concept. And here, for this, say a dust type material, a pulley is there. So you can just draw the free body diagram for M1. Suppose it is coming vertically downward, but for M2 there is only tension force is acting. So you can solve it simply, just add it together and substitute. But what about the reaction here with respect to the string? So here the two strings are makes an angle of 90 degree and simply you can say the reaction on the pulley is root 2T. Good. And here also another concept. You can easily find what is the acceleration. How? Simply, its weight. What is that? m2g minus this one, this component. What is that? m1g sine alpha. So similarly, you can say, but here also, if it is alpha, this is 90. So this angle become 90 minus alpha. So the two tensions are acting like this one. They makes an angle of so much. then what is the reaction on it? So that is, you should know that relation, it is very important. The reaction you can finalize as a t into root over 2 into 1 plus sine alpha. It is a good concept. Then what about this one? Look at the figure, a double inclined plane. If you solve, you get the value, acceleration, tension, the reaction. But if you look into these three relations, A, T and R, then you get all the equation of these three figures. So my advice is, all the NEET aspirants, especially KEAM aspirants, must study these three relations, A, T and R. Then for this situation you can say that alpha and beta become 90. So you sin 90 become 1. So for this pulley system, m2 minus m1 by m1 plus m2 into g. The tension is what? So again 1 plus 1, 2 m1 m2 by m1 plus m2. What about R? So alpha plus beta. So 90 plus 90. What is that? 180. Cos 180 minus 1. So 2t. Good. So you can easily find the relations if you know carefully these three relations for the double inclined plane. So you just know how that angle varies for the respective figures. And here an added question. The figure shows the three blocks of mass m each hanging on a string passing over a pulley. Calculate the tension in the string connecting A to B, A to B and B to C. So at first we can easily find what is acceleration, and here it is 2m, here only m, so you get it. Then you can intuitively write the equation of motion, you get the answer. So we can move to the next concept, an extra one. The system as shown in the figure is released from rest. Calculate the tension on the strings and the force exerted by the strings on the pulley, assuming the pulleys and the strings are massless. So we can easily find what is the acceleration as our usual concept. What is this one? 2g. What is this one? 1g. Difference by the total mass 2 plus 3 plus 1 into g. So you get the concept. It is a thing, see, this is T2 and this is T1. So for this one you can just write the relation. So it is moving upward direction. So T1 minus its weight g equal to 1 into the acceleration. Good. So you can solve it. What about for this one? And it's moving downward. So 2 into g is greater compared to this tension T2 equal to 2 into A. Yes, you get the value T1 and T2. So what is the reaction or the force on the pulley? So root 2 times T1. Good. And what is the force on this one? Root 2 times of T2. Reason that two tensions makes an angle of 90 degree. Good. A very good question is waiting. You must go it. You must study it so carefully. A 60 kilogram painter stands on a 50 kilogram platform. A rope attached to the platform and passing over an overhead pulley allow the painter to raise himself along with the platform. Question number 1. To get started, he pulls the rope down with a force of 400. Find the acceleration of the platform as well as that of the painter. Again, two questions are waiting. What force must he exert on the rope so as to attain an upward speed of 1 meter per second in 1 second? What force should he apply now to maintain the constant speed of 1 meter per second? So, based on this free body diagram, you can just write the relation. The upward one as 2t minus the downward one, the painter plus that block together, platform, So equal to together move with an acceleration a. So that's all. You get the answer. But the second case it is given to attain a speed of 1 meter per second in 1 second means it must move with an acceleration of 1 meter per second square, not 0.67. So you can just take this relation, in place of t it is denoted as f, then the a is given as one value. So you can just substitute. The same concept coming in the next case, but here it must move with a constant speed of 1 meter per second. You know, the total effect should equal to what? 0. Constant speed. So there you can use this concept. Again, this formula we can use it. So we just go through the string force and the connected system. In the coming video, we can wait for spring force with the friction. Thank you. God bless you.